Hello everyone. Today we're going to be going over question 9 from paper 2 of the sample assessment material for a further pure maths IGCSE. Now this question is about both quadratics and calculus in terms of volume of revolution of stuff. Alright, so this function, we have here a function fx is 7 plus 4x minus 2x squared. And given that fx can be written in the form p times x plus q squared plus r, where p, q, and r are constants, find the value of p, q, and r, write down the maximum value of fx and the value of x for which this maximum occurs. Now, basically, these 5 marks here, they're just from your knowledge of being able to complete the square and interpret the result. This value r is the maximum of x, because this x plus q squared, since it is something squared, it'll always be greater than 0 or equal to 0. And if it is equal to 0, that's the lowest value this can go. And r is a constant, it never changes. So r is the maximum value of this. Especially in the case when minus 2x squared is the leading term, and so the graph tends towards negative infinity on both sides. And find the value of x for which this maximum occurs. So you know that x plus q squared must equal 0, so x plus q is equal to 0, and x is equal to minus q. So that's the value of x for which this maximum occurs. Now, secondly, curve C has equation y is 7 plus 4x minus 2x squared. And then the line with equation y is 4 minus x intersects C at 2 points. Find the x coordinates of these 2 points. So if we call this y1 and we call this y2, just set y1 is equal to y2, and then solve for x. So you have this expression here is equal to this expression here, then you solve the quadratic equation, and you find the x coordinates of those 2 points where they intersect. And next, the finite region bounded by the curve C and the line L is rotated 360 degrees about the x-axis. Use algebraic integration to find to 3 significant figures the volume of the solid generated. Now, the way you do this is you first find the volume of the outermost curve, the volume that the outermost curve would generate, and then you should find the volume that the innermost curve would generate, and then you calculate the difference. So this is equivalent to the volume the outermost curve creates, so pi times y1 squared dx, and then subtract the inner volume, so minus pi times y2 squared dx. Or this could be equivalent to pi times the integral of y1 squared minus y2 squared, or y2 squared dx. And that is how we can calculate d. You might have the intuition to do y1 minus y2 squared dx, because you would think that it is the difference between the 2 lines that you're finding to get the area. However, this expands to y1 squared plus y2 squared plus 2y1 y2. Now, this is completely irrelevant and it doesn't help you at all, because there is no reason to be multiplying the 2 functions together. And secondly, you find the sum of the outer and inner volumes rather than the difference. So this doesn't work either. So this expression is not the way to go. You want to find pi times y squared minus y1 squared minus y2 squared dx, because it is the difference in area from the outermost volume and the innermost volume. Alright, so let's get started. Find the value of p, q, and r. So you know that fx is equal to minus 2x squared plus 4x plus 7. And we can set this minus 2x squared plus 4x. We factorize out the minus 2 to get minus 2 times x squared plus 4x, or rather x squared, or this is just wrong. It's minus 2 times x squared minus 2x plus 7, because if you distribute minus 2 into here, you'll get minus 2x squared plus 4x. and then this would be equal to minus 2 times x minus 1 squared, because that's x squared minus 2x plus 1, and then subtract 1 to get rid of that plus 1 I mentioned just a few seconds ago, and then plus 7. And you distribute the negative 2 to the negative 1, but not to here. So then you get negative 2x minus 1 squared, and then minus 1 times minus 2 is positive 2, and positive 2 plus 7 is 9. So you get this form, minus 2 times x minus 1 squared plus 9. And therefore, you're looking for the values p, q, and r. So p is minus 2, q is minus 1, and r is 9. And make sure you're looking for whether they want it in the form x plus q or x minus q, because there is a reason to do both. There is a reason that they would want you to find it in the form x minus q, because if you find it in x minus q, the value of x for which the maximum or minimum occurs is just straight up positive q with no change. Alright, so p is minus 2, q is minus 1, and r is 9. Now, let's get started with part B, and hence write down the maximum value of fx. So we know the maximum value of fx would be r, so maximum value of fx would be 9. And then the value of x for which this value occurs. So we already proved earlier that it would be x would be equal to negative q at this point. So negative 1 is positive 1, so x is equal to 1. Now, if it is a question with the instruction, the imperative write down, they usually do not expect any working. You can put it there if you want, but you don't have to. It's normally a B mark, which means independent accuracy. That means that as long as you write down the correct answer, they have to give you the mark. Alright, so now find the x-coordinates of the 2 points in which this line intersects to this line. So you have y1 is equal to y2, so 7 plus 4x minus 2x squared is equal to 4 minus x. And then add x to both sides. 7 plus 5x minus 2x squared equals 4. Subtract 4 from both sides. 3 plus 5x minus 2x squared is equal to 0. And now we can factorize this. We're looking for two numbers to split this 5x into. And the product of these two numbers will be minus 2 times 3, so that's minus 6. And then the sum of these two numbers will be 5. And if we look at the factors of minus 6, the first one that hits us is minus 1 and 6, which satisfy these criteria because 6 minus 1 is 5, 6 times minus 1 is minus 6. So we'll split this up into 3, and then since we can factorize the 2 out from 6 and 2, that's where we're going to go with this. You can do it the other way around, but it really doesn't matter. This is just what I'm doing because I know that 6 and 2 you can factorize that the 2. So 3 minus x plus 6x minus 2x squared equals 0. And we'll factorize this one first because in this question we've been writing all the expressions backwards with the highest degree at the end. So 3 minus x plus 6x minus 2x squared, and then you get factorize the 2x out from all of those. You get 3 minus x plus 2x 3 minus x equals 0. And then, of course, this is just 3 minus x. So that is clear to us what this is, because it will be 1 plus 2x times 3 minus x if you're factorizing the 3 minus x out. And so we can gain from this knowledge that either 3 minus x is 0 or 1 plus 2x is 0. X must be equal to negative 1 over 2 or positive 3. Alright, so now the finite region bounded by the curve C and line L is rotated 360 degrees about the x-axis. Use algebraic integration to find 3 significant figures, the volume of the solid generated. Now, what we're doing here is we're taking the So like I looked up the graphs that we are doing on a calculator earlier, and the area of the thing that we're integrating, we have the curve C, and then we have the line L, and it looks something like this. Now the thing is, so this should be the x-axis because they cross before the x-axis, before the y-axis as well. This is the y-axis, sorry. The thing is, we want to find the volume of rotation of this solid. So if we rotate this outer curve, we'll get a kind of spinning top base shape, like a loaf of bread almost. If you've ever seen bread before it was made, and it's in this dough form, yeah, it'll look something like that, with a point in the middle where it goes out, because it's a curve. And then we'll be subtracting from it this partial cone sort of shape. So it'll have the top like that, and then, yep, and then it'll look something like that, where the top part is of a smaller area than the bottom part. And then since this part is a sub part of this, the final area we're looking for will be almost like a donut with a sharp edge here and sort of curve around here. And this is so that you can visualize we're taking the outer area of this, so the integral pi times the integral of y1 squared, and then we're subtracting the inner area, which is pi times the integral of y2 squared, to get our final value for the area encompassed by this sort of area of rotation. Volume of rotation, I should say. So let's get down to business. So we want to find pi times the integral of y1 squared minus y2 squared dx. Now this is quite a daunting challenge. So we know that y1 is equal to minus 2x squared plus 4x plus 7, and y2 is equal to minus x plus 4, or just 4 minus x. Now, y2 squared is equal to, well, 4 minus x, so that would be minus x times minus x, positive x squared, minus x times 4 times 2 is minus 8x, and then positive 4 squared is just plus 16. So it's the binomial squaring, like a minus b squared is a squared minus 2ab plus b squared. Alright, so now we need to square this. And what I'm going to use here is something called polynomial long multiplication. And it's kind of like regular long multiplication, except you don't carry digits because you're working in base x rather than base 10. Like, so say we have 2x squared plus 4x plus 7. So minus 2x squared and 4x and 7. And this will be our x squared column and our x column and our constant column. And then we know that the highest x term is going to be minus 2x squared times minus 2x squared would be positive 4x to the power of 4. So let's make an x cubed column and an x squared squared column. And then again we're multiplying by minus 2x squared plus 4x plus 7. Now, beyond this point, I'm not going to write out the x terms because it will become very slow. I'll write it out for the first, but not for the other column. So 7 times, so first you just do it like a long multiplication, like 7 times 7, 49. 4x times 7, 28x. Minus 2x squared times 7, minus 14x squared. And then, and so on, and so on. Like, you even do the same process in which you just put a 0 here before you start multiplying by the second term in the bottom row. So, like, 7 times 4, 28, x, and then 4x times 4x, so 16x squared, and then minus 2x squared times 4x, so minus 8x cubed. Then once again, 0 and a 0, and we're multiplying by minus 2x squared, so 7 times minus 2x squared, minus 14x squared. And then 4x times minus 2x squared, minus 8x cubed. And then minus 2x squared times minus 2x squared is positive 4x to the power of 4. So now we just add this all up, and we get y1 squared is equal to 4x to the 4 minus 16x cubed minus 12x squared plus 56x plus 49. And then from this, we subtract y2 squared. So y1 squared minus y2 squared. And y2 squared, as we know, is x squared minus 8x plus 16. And as we subtract this, we get 49 minus 16, 33. 56x minus 8x, so that's plus 8x, so 64x. Then minus 12x squared minus an additional x squared, so minus 13x squared. And then furthermore, we'll get minus 16x cubed, and then minus nothing, so it remains at minus 16x cubed. And finally, 4x to the power of 4 minus nothing, so this is our y1 squared minus y2 squared. So since we want to find the integral from the limits of negative 1 over 2 to 3, because these are our points of intersection, and we know that volume is equal to, from negative 1 over 2 to 3, y1 squared minus y2 squared dx, we can just evaluate this integral in order to get the final volume of rotation. So y1 squared minus y2 squared dx from minus 1 over 2 to 3 is equal to now I'm just writing out this expression again so it's clear what I'm doing. So 4x to the power of 4 minus 16x cubed plus, or rather, minus 13x squared, should be a minus symbol, plus 64x plus 33 dx. And then this is equal to the bounds of, so 4x to the power of 4 integrated, that's just 4 over 5 x4, and then minus 16x cubed integrated, that's just minus 4x to the 4, and then minus 13x squared integrated, so minus 13 over 3 x cubed, and then plus 64x, integrate that, and you'll get plus 32x squared. And finally, plus 33 dx. And then 33, the integral of that would be plus 33x. And then this is in the bounds from 3 to minus 1 over 2. So this is equal to, first let's calculate what it is for 3. So this is not x to the power of 4, this is x to the power of 5, my bad, because 4 times x to the power of 4, you integrate that and you'll get 4 over 5 times x to the power of 5. And first we do that with 3, so 4 over 5 times 243 minus 4 times 81 minus 13 over 3 times 27 plus 32 times 9 plus 33 times 3. And then minus the bound for negative 1 over 2. So 4 over 5 times minus 1 over 32, which is x to the 5th. And then minus 4 times positive 1 over 16. And then minus 13 over 3 times negative 1 over 8. Plus 32 times positive 1 over 4. And finally, plus 33 times negative 1 over 2. So I'm going to use the calculator to figure out what the value of this is. So first we have 0.8 times 243, which is 194.4, and then minus 4 times 81. So that brings us to minus 129.6, and then minus 13 over 3 times 27. That brings us to negative 246.6, and then plus 32 times 9, so that's 41.4, and then plus 33 times 3, so plus 99, which brings us to 140.4. So this top expression is equivalent to 140.4. And then next, we have this expression down here. So we want to find this first. So 4 over 5 times minus 1 over 32 is equivalent to minus 0.025, quite the small number. And then minus 4 times positive 1 over 16, so minus 4 over 16, that's minus a quarter, and you get minus 0.275. And then minus 13 over 3 times minus 1 over 8, so minus 13 over 3 times minus 1 over 8. And that brings us to 4/15. Plus 32 times a quarter, so plus 8. And finally, plus 33 times negative 1 over 2. So that would be minus 33 over 2. And that brings us to minus 247 over 30, or 8.23 recurring, but let's just put it in fractional form. So we're just finding this integral. We need to remember to multiply by pi at the end, otherwise our answer will be incorrect. So make sure you do that. If it helps you, just put a pi at every step so that you remember what you're doing. So it's pi times this, and then pi times this minus pi times this. But regardless, what's in this brackets is minus 247 over 30. So this will be equal to pi times 140.4 minus negative 247 over 30, which is equal to pi times 148.6333 recurring, which ultimately is equal to 466.9453 blah 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 blah. And if you go all the way back to the beginning of the question, you will recall that we need to find the volume to 3 significant figures. So in the end, the volume will round to 467 at 3 significant figures. Now, I want to make a note about the technique that I use in this question. In the mark scheme, they are not explicitly using that formula, the pi times integral of y1 squared minus y2 squared dx, but they are using an equivalent formula in which they make the integral of y1 squared dx equal to pi times integral of y2 squared dx. And then it is a fairly trivial exercise to go from here to my own formula, because if you just subtract this integral from both sides, you get pi minus 1 squared minus y2 squared dx equals 0. So this is equivalent, and this is what you'll see in the mark scheme. But I prefer using this formula because it makes clear that we are first finding the outer volume. We are first finding the outer volume of the solid, and then we are subtracting the inner volume of the solid. Because this is a clearer way of laying out what you are really doing. You are finding the two solids and calculating the difference between them. Alright, so now I'm going to go to the mark scheme and see what we got correct. Our final answer for part E was 467, which I remember correctly seemed to be correct. And we did all this polynomial long multiplication stuff, and all of this is fairly simple quadratic equation stuff. So we got the first 8 marks in about half a page, and then we got the next 5 marks across 2 pages, which is quite the joke. So my advice to you in an exam, never do these until the very end, because I mean, you could do them if you know you're fast, but generally these kinds of find the volume of rotation of a solid give too little marks for the amount of work that you have to do. And in the end, it's simply better to have completed a solid 80% of the paper rather than having wasted a lot of time on this and only being able to complete 65, maybe 70% of the paper afterwards. Alright, so let's scroll down to the mark scheme and see how we did. Alright, so this is the mark scheme for question 9. And we got p is minus 2, q is minus 1, r is 9, yep. And then the values are 9 and 1, yep. And then, of course, we do not have to give any working for this because they are B marks. And B, if I may remind you, that just stands for independent accuracy. So that means you just have to have the correct answer with no working whatsoever. But, yeah, okay, so if something is like write down, you don't need working. Alright, so here we got that is equal to 4 minus x, so we solve this quadratic for negative 1 over 2 and 3. Yep, and then, yep, like I told you, they are using this form because this is y2 squared, and this is y1 squared. And in an exam, make sure you're writing out this entire form. Make sure it's clear what this is. And if you want to use y1 and y2, or you might not even have to use it at all, but just make sure you're clear to the examiner about what y1 and y2 are when you're doing it in the exam. I just did it here for demonstration purposes to show the principle of how you would find the volume of rotation. Alright, so they are using integral y1 squared dx is equal to the other one. But we just used the other formula, which makes it clear what we're doing. Alright, so we get pi times this definite integral, and then pi times these bounds, which is equal to pi times such a number, and then which rounds to 467. So that's correct. We collected our 5 marks there, and we got this correct, and we got these correct, and we got these correct. Alright, so I'm quite satisfied with the performance here, and after this half an hour long question, I thank you so very much for watching to the end. So 13 marks. Thanks for watching.